Hi everyone, this is Dao Chai. I'm at the University Library right now. If you guys hear students talking in the background, excuse them, sorry about that. Okay, so we are moving on to part two of our CPA practice test sample question in business environment and concept section, okay? Okay, so we left off at PR outputs is constrained by the capacity of 300 units in the assembly line um, operation. So what can managers do to relieve the bottleneck constraint of the assembly operation? So here are the desirable outcomes, okay? In one, so we eliminate idle time at the bottleneck operation. Time when the assembly machine is neither being set up to assemble nor assembling SM engines. Okay, so manager is evaluating promptly, permanently positioning two workers at the assembly operation to unload SM engines as soon as they are assembled and to set up the machines to begin assembling the next batch of engines. This action will cost $320 per day, and bottlenecks output will increase by 300 SM engine per day. Should managers incur the additional costs? So we say yes because the contribution margin will increase by 720 per day, right? So which is greater than the increment cost of 320 per day, and all other costs are irrelevant. Okay, so second, shift the production that do not have to be made on the bottleneck machine to a non-bottleneck machine or to outside processing facility. Suppose Barton Corporation, an outside contractor, offers to assemble 5 SM engine each day at 75 per engine from engines that have gone through the forging operation at PR. Barton's quote price is greater than PR's own operating cost in the assembly department of 60 per engine. Now the question is, should our managers accept the offer? So we say yes because assembly is the bottleneck operation. So getting Spartan to assemble additional SM engine will increase contribution margin by $1,200 per day. So while the relevant cost of the increased capacity will be $375 per day, the fact that PR's units cost is less than Spartan's quoted price is irrelevant. So let's suppose a Gemini, another company, right? An outside contractor offers to forge for us do a forging operation for 8 SM engines per day at 65 per engine, right? $65 per engine from direct material supplied by us. Gemini's price is lower than ours, but our operating costs, right, is lower than ours because our operating cost is $80 per day for the forging department. But should PR's managers accept Gemini's offer? So we say no because our operating costs are fixed costs. So what that means is that this will not save any cost by subcontracting the forging operation. Instead, its cost will increase by $520 per day. So with no increase in the contribution margin, which is the constraint by assembly capacity. So that's why we say no to that offer. Okay, so third, let's reduce setup time and processing time at the bottleneck operation. So for example, by simplifying the design or reducing the numbers of parts in the product. So suppose PR can assemble 10 more SM engine each day at cost of $1,000 per day by reducing setup time at the assembly operation. So the question is, should manager incur this cost? So we say yes because contribution margin will increase by $2,400 per day, which is greater than the increment cost of $1,000 per day. So will PR's manager find it worthwhile to incur costs to reduce machining time at the non-bottleneck forging operation? Again, we're going to say no, right? Other operation costs will increase while the contribution margin will remain unchanged because of bottleneck capacity at the assembly operation will not increase. Okay. Okay, so fourth, improving the quality of the parts or products manufactured at the bottleneck operation. So poor quality is more costly at the bottleneck operation than at non-bottleneck operation. Okay, so remember that. The cost of poor quality at the bottleneck operation is the cost of the material wasted, right? So if PR produced 5 defective SM engines at the forging operation, the cost of the poor quality is $2,800, and there would be no contribution margin, right? No contribution margin is forged because forging has unused capacities. So despite the defective parts, forging can produce and transfers 300 good quality engines to the necessary operation, right? So what we want to look is at the bottleneck operation, right? The cost of poor quality is the cost of materials wasted plus the opportunity cost. Okay, so that's where we're going to run into problems, right? Opportunity cost of loss of contribution margin. So bottleneck capacity is not wasted in producing defective engines could be used to generate additional contribution margin. So if PR produced 5 defective units at the assembly operation, the cost of poor quality is the lost revenue of $4,000. So what else? What about direct costs of $2,800, and then plus the forging contribution, right? So that's the issue right there, is the forging contribution cost of $1,200. Okay, so the high cost of poor quality at the bottleneck operation means that bottleneck time should not be wasted processing units that are defective. So that is, engines should be inspected before the bottleneck operation to ensure that only good quality parts are proceed at the bottleneck operation. So furthermore, qualities need improvement programs should place special emphasis on minimizing defective at bottleneck machines. Okay, so the high cost of poor quality at the bottleneck operation means that bottleneck time should not be wasted processing units that are defective. So that is, the engine should be inspected before the bottleneck operation to ensure that good quality, right? That only good quality parts are processed at the bottleneck operation. So furthermore, quality improvement programs should be place special emphasis on minimizing defectives at bottleneck machines. Okay, so if this is successful, the action, right? If we take this action, it will increase the capacity of the assembly operation until it eventually exceeds the capacity of the forging operation. The bottleneck will then shift to the forging operation. PR would then focus continued improvement actions on increasing forging operation efficiency and capacity. So for example, the contract with Gemini Industry to forge 8 SM engines per day at 65, right? And then for the direct material supplied by us will become attractive because the contribution margin will increase to 1920, right? Which is greater than the increment cost, right? Okay, so let's just kind of look at Apple. Okay, so let's see what they're doing. So the experience of like Apple Watch illustrate how many of the issues discussed it, right? That we discussed it. So during the final testing, the company found that a tapped engine, right, motor designed by Apple to produce sensations, right, on the risks made by one of their suppliers. One of their two suppliers started to break down. So as a result, Apple had to scrape some completed watch and move the production of the components to a second supplier. So while the second supplier parts did not experience the same problem, it took time from that supplier to increase production. So resulting, Apple had to ask other components suppliers to align their productions to the output of their tapped engine bottleneck. Okay, so the theory of constraint emphasis management of bottleneck operation as the key to improve performance of production operation as a whole. So it focused on short-term or short-run maximization of contribution margin. So because TOC regards operating costs as difficult, right? Like to change in a short run, it does not identify individual activities and drivers of costs. So therefore, sometimes TOC is less useful for the long-term management costs. Okay, so that's why we don't want to use it long-term, but we can use it as a short-term solution, which is effective. So in contrast, right, so what I just said, activity-based costing, right, system takes a longer perspective and focus on improving process by eliminating non-value added activities and reducing the cost of performing value added activities. So this system, the AB system, right, which we'll do to design the system in general, right, are therefore more useful than TOC for the long run of control and capacity management. Because then, but then we can use the short run TOC to emphasize and maximize our contribution margin and manage our bottleneck components. And the long run strategy components managers could focus on that while they're doing the design. So basically, let's say we're going to design our production, right? So our manufacturing. So we well, okay, so let's design it through ABC, right? So let's design it through activity base, right? And but then, you know, say a month, 2 months, 3 months later, we start getting bottlenecks because of maybe we need more product, right? Or we need to expand, something happens, right? And we need to increase production. So bottleneck happens. Now we could use our short-term TOC, right? So that way we could manage the problem and then we can come back and refocus on our ABCs. All right, thank you. Oh, well. All right. Okay, thank you, everyone.